Okay, so we're going to start with the exponential unit, okay? And we're going to start exploring the exponent laws. That's the first thing that we're going to explore. So we're going to find out where did they get these formulas from, or how did they come up with these formulas, the exponent laws. Okay, that's the first thing that we're going to do. So we're going to start with the multiplication law. The multiplication law is when you are multiplying two things. Now the important part right here is that we have the same base. Okay? So you have the same base and then you're multiplying. So I have a to the power of 4 times a to the power of 5. It's very important that it's the same base. If there are different bases, I cannot use this law. Okay? So what happens? If I have a to the power of 4, that means it's a times a times a times a. That's a to the power of 4. That's what a to the power of 4 means. Right? Now I'm multiplying by a to the power of 5. So that's another a times a times a times a times a 5 times. Right? So altogether, it gives me how many a's multiplied together? 9 a's multiplied together, so which is a to the power of 9. Okay? So, if I have a to the power of 2 times a to the power of 4, that's the same thing as writing a times a. That's for the first part. Right? And then multiplied by a times a times a times a 4 times. So that's a to the power of 6. How about the next one? What do you have? So a times a times a times a times a. So that's 5 times. And then multiplied by another a. So that gives me a to the power of 6. Okay? Same with the next. So do you guys notice any pattern? Do you notice anything?
It's just like addition.
And adding what?
The exponents.
The exponents. Right? So that would be a to the power of 8. Right? Because I have 1, 2, 3, 4, 5, 6, 7, 8. Right? So for the next one, which is a to the power of 4 times a to the power of 3, what do you think the answer is going to be? A to the power of 7. Okay? Because what's happening here is the same thing if I'm adding my exponent. Right? 4 plus 3 is 7. 6 plus 2 is 8. 5 plus 1 is 6. 2 plus 4 is 6. 4 plus 5 is 9. Okay? So the rule says, if you have multiplication, have the same base, you can add the exponents. You keep one of the bases, you add the exponent. Okay? That's in the rule of multiplication. So keep the like base and add the exponent.
Excuse me, miss.
Yep.
What if the base isn't the same?
Then you can't do this.
Okay.
There's no way for you to be able to do it. Okay? So this says that if I have a to the power of m, whatever the number is, times a to the power of n, my answer is going to be base a, m plus n. Are we okay with that? Now with the division law, okay, so this is called the multiplication law. We're going to look at the division law right here. So the division law is the same thing. It applies the same concept. So you have the same base divided by each other, right? So in this case, I have a to the power of 5 divided by a to the power of 4. Okay? So I want to expand the numerator, so it will be a times a times a times a 5 times, divided by a times a times a times a 4 times, right? So what happens here is I can simplify, okay? So if you look here, I can simplify a with an a with an a, until I have no more a's in one of them, okay? So in this case, how many a's do I have left? One a in the numerator, right? So it's a to the power of 1, but I don't have to write that power, okay? So same thing if I have here, so I have a times a times a times a divided by a times a. So what happens? A squared, right? So I have 2 a's left. If I do the simplify, so 1 and 1, 1 and 1. So I have a squared left. What do you think would be the answer for the next one?
A4.
A4. What's happening here? Subtracting the exponent. So you're keeping the base the same and you're subtracting the exponent, right? So what would be the next one?
A4.
And the next one?
A.
Okay? Because what I'm doing is technically I'm doing A5 minus 1, which is A4. Right? A6 minus 2, which is A4. Alright, so let's write the rules down. So you're going to keep, again, if the base is not the same, you can't do this. Keep the like base and subtract the exponents. Are we good with that? So the rule for this, if you have a m over a n, you can write it either this way or this way, same thing, because they both mean division, equals to a m minus n. So that's your rule. Are we good with that? Power of a power law. So it's when you have like something to the power and then to the power. So if you look here, I have a to the power of 4, and then all of it is to the power of 5. Okay? So that means I have a to the power of 4 multiplied by itself 5 times. That's what this means, right? A to the power of 4 times 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 a to the power of 4. If I want to put all of this together, how many a's do I have multiplied together? 20. Right? So it's 4 plus 4 plus 4 plus 4 plus 4. Okay? 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. Are we okay with this?
Why is the 5 there?
Because this is the question. The question is a to the power of 4 to the power of 5. So you have a to the power of 4 multiplied by itself 5 times.
I just didn't know that you could put a power to a power.
Yes, we can. Okay? So, for the next one, I have a to the power of 2 to the power of 3. So that means I have a to the power of 2 multiplied by itself 3 times. So that's 2 plus 2 is 4, plus 2 is 6, so that's a to the power of 6. How about the next one? A5 times A5, which is a to the power of 10. Next one is
A6 times A6 times A6.
which is?
A to the power of 18.
Do you notice any pattern here with the exponents? They're multiplied. So if you look here for a second, please. 4 times 5 gives me 20. 2 times 3, 6. 5 times 2, 10. 6 times 3, 18. So the last one, a to the power of 4 to the power of 3 is a to the power of 12. Because if you multiply 4 times 3, you get 12. Okay? So the formula for the power to the power is you multiply your exponents. Okay? So you keep the base. In this case, I only have one base. I keep it as is. I don't do anything to it. It stays the same. Right? It did not change. It's not B now. It stays as A. And then you multiply your exponents. So you should be getting, if I have a to the power of m to the power of n, that will be a m times n. Are we good with that? Well, that's the formula. Are we okay with that? Okay, so what I want you to do is I want you to try to do the questions in the next, like the questions A to F, and see what you can get.